Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 5.4, Day 2 notes. What we're going to do first is go ahead and do a review from our last section. Solve each equation. Remember, if I only have one fraction on each side of the equal sign, I can cross multiply. That would give me 14 is equal to x times 9 minus x. So 14 is equal to, I'm going to distribute my x to both. So it would be 9x minus x squared. Now, if you remember from our last section, I went ahead and brought everything over so I can factor. So 0 equals, I want my x squared first, so negative x squared plus 9x minus 14. I don't want my x squared to be negative, so I need to take out a GCF of negative 1. X squared plus 9x minus 14. I'm sorry, it's going to be minus 9x plus 14, since I took out a negative 1. So minus 9x plus 14. So what can possibly multiply to 14? That would be 7 and 2. So x and x, 7 and 2, both will be negative. Now that I have it fully factored, don't forget our negative 1. I can set everything equal to 0. So negative 1 equals 0, which is not true. X minus 7 equals 0. If I add 7 to both sides, oh, my smartboard messed up. Add 7 to both sides, then x equals 7. X minus 2 equals 0. Add 2. So x equals positive 2. Now, before I box my answers, I have to double check for my restrictions. The only restriction I have comes from x, so x cannot equal 0. So 7 is not 0, so I'm good, and 2 is not 0, so I am good. On to the second review problem. We're going to do the same thing here. 2x times 1 would get me 2x. Then I have 7 times x minus 5. So 2x equals 7 times x is 7x. 7 times negative 5 is negative 35. Subtract 2x from both sides. 0 equals 5x minus 35. I can take out a GCF of 5, so I have 5 times x minus 7. And now that it's fully factored, 0 equals 5, which is not true. X minus 7 equals 0. Add 7 to both sides. So x would equal 7. Shouldn't have boxed it yet, but it's going to work out fine. From 2x, I know x cannot equal 0. From x minus 5, I know that x cannot equal 5. All right. Well, now on to our new information. Above, we saw that there was only one fraction on either side of the equal sign. Well, in this example, the first example we have here, I have two fractions on the left and one fraction on the right, which means I cannot cross multiply. So when there are multiple expressions on each side of the equation, we cannot cross multiply. When we will then multiply all the numerators of the expressions by the LCD. So the first step to each one of these problems is I must find an LCD. Well, we're going to do it just like we did in our previous unit, where I break up everything and I circle what they share, so 3 and x. So my LCD then would be 3 times x times 3 times 4. 3 times 3 is 9. 9 times 4 is 36. I also have the x. So I'm going to take each one of the numerators and multiply by 36x. So I have 2x times 36x over 9x plus 9 times 36x over 12 equals 2 times 36x over x. What I'm going to have to do now is I want to simplify each fraction individually. So 36x and 9x would simplify. The x's would completely go away. 36 divided by 9 would be 4. Okay? 36x and 12, I can simplify the 36 and using the 12, which would give me 3. Here, the x's would go away. Okay? So I have 2x times 4, which is 8x. plus 9 times 3, which is 27, x, don't forget about the x right here, is equal to 2 times 36, which is 72. Now I can combine like terms, so 8x plus 27x would get me 35x is equal to 72. From here, what I can do is divide by 35x. So x would equal 72 over 35, and I am done. The one thing I do have to check here again is for my restrictions. So 9x means x cannot equal 0, and x also means that x cannot equal 0. So the fact that 72 over 35 is not 0, I am good. That is a little bit of a tricky situation with that problem, but moving on, they get a little cleaner. So we will see how that works in 1 second. Extraneous solutions are solutions that make the denominator of the original solution equal to 0. What that means is that my solution will be the same as my restriction. So if it's not the same as my restriction, my answer is good. If it is the same as my restriction, then my answer would not be good. That is why we need to check all of our answers against the original problem to make sure none of them are extraneous. We'll talk about that again in 1 second. So problem number 1. I have x minus 7 and 2 and x minus 7. So the x minus 7s are shared. So my LCD is going to be 2 times x minus 7. Okay? Because of this 2 and then the x minus 7s are shared. So I'm going to take 2x minus 9 times 2 times x minus 7 over just x minus 7 plus x times 2 times x minus 7 over 2 is equal to 5 times 2 times x minus 7 over x minus 7. Again, at this point, what I'm going to do is I'm going to simplify each fraction individually. So the first fraction, I can get rid of x minus 7, which leaves me with 2x minus 9 times 2. I'll take the 2 times the 2x, which would get me 4x, and I would take the 2 times the negative 9, which would get me negative 18. Now, for the second fraction, I can get rid of this 2. So I have x times x, which would be positive x squared, x times negative 7, which is negative 7x. This is going to be equal to, on my final fraction, I can get rid of the x minus 7. So 5 times 2 is 10. Now what I'm going to want to do is rearrange this in standard form. So I want my x squared to be first. While I'm doing that, I'm going to combine like terms. X squared will not combine with anything else, so it's x squared. The 4x is my next largest x. Well, that will combine with negative 7. So 4x minus 7x is negative 3x. Negative 18 will not combine with anything on the left, so I'm going to keep it for 1 second. All that's equal to 10. In order to factor successfully, what I have to do is have these set equal to 0. So I'll subtract 10. So x squared minus 3x minus 28 is equal to 0. Now I have 3 terms, so I can factor this using generic factoring. So if I make 2 sets of parentheses, all that's equal to 0. I'll have x at the beginning. What multiplies to 28 that can add to 3? Well, that would be 7 times 4. I need it to be a negative 3, so it would be negative 7 and positive 4. Now that I'm fully factored, I'm going to set everything equal to 0. So x minus 7 is equal to 0. Add 7. X equals 7. X plus 4 equals 0. Subtract 4. X equals negative 4. Before I box my answers, however, I want to double check that neither one of my answers are one of my restrictions. So my restrictions come from x minus 7 and x minus 7. Those are the same. So I know that my restriction is x cannot equal 7. Check our 2 answers. My first answer is 7. Well, since it cannot equal 7 according to my restriction, I'm going to get rid of x equals 7. So the only answer that will work is x is equal to negative 4. All right. Now on to the back. Let's look at problem number 2. I only have one denominator here, which means that my LCD will just be that denominator. So my LCD is x. So I'm going to take x times x plus 8 times x over x is equal to 6 times x. Well, x times x will get me x squared. 8 times x over x, that one x can go away, so plus 8 is equal to 6x. Now again, I want to get everything to the same side of the equal sign, so x squared. To do that, I would need to subtract my 6x, add 8, it's all equal to 0. So now I have three terms. I can use generic factoring, so two sets of parentheses. What multiplies the 8 that could add to 6? Could be 4 and 2. Needs to multiply to a positive, add to a negative, so minus 4, minus 2. Now that it's fully factored, set them equal to 0. So plus 4, x equals 4. X minus 2 would be equal to 0, so add 2. X would equal 2. Before I box my answers, I need to double check my restrictions. I only have one denominator is x, so x cannot equal 0. 4 is not 0, so it's good. And 2 is not 0, so it is also good. Okay? On to problem 3. I need to check for my LCD. Well, nothing is shared, but I have 3 and x, so my LCD is going to be 3x. I want to multiply every numerator by 3x. So 10 times 3x over 3 is equal to 4 times 3x over x plus 2 times 3x. Well, looking at my first fraction, 10 times 3x, I can get rid of the 3's, which leaves me with just 10x is equal to 4 times 3x, I can get rid of the x's, so I have 4 times 3 is 12. 2 times 3x would be 6x. Now, I want to get everything to the same side of the equation again. So what I'm going to do is subtract my 10x, which leaves me with 0 equals 12 minus 4x. What can multiply to 4 and 12? Actually, before I continue here, since my 4x is negative, remember I do not want my x to be negative. So I'm going to pull out a GCF that will be negative to change my x to a positive. So now that we know that, what we're going to do is figure out what multiplies to 12 and 4. Well, that would be negative 4, which would leave me with negative 3 plus x. Now that I'm fully factored, 0 can equal negative 4. That's not true. Negative 3 plus x would equal 0. Add 3 to both sides. So x equals 0. Before I go ahead and box that answer, what I want to do is check my restriction with x. The only denominator that has a variable is the x. So x cannot equal 0 is my restriction, which means that my answer is no good. So in this case, I have no solution. I have no answers that are valid, so I have no solution. Okay? On to problem 4. Here, I have the x minus 6 is shared. The 2 is not. So my LCD is going to be 2 times x minus 6. I need to multiply 2 times x minus 6 by all of my numerators. So I have x plus 4 times 2 times x minus 6. You know what? I'm not going to write that right there. I'm going to run out of room if I try. So I'm going to go ahead and drop down here. So I'm going to have x plus 4 times 2 times x minus 6. That takes care of my first fraction. Plus, over x minus 6. Plus, now I have to look at my second fraction. X times 2 times x minus 6 over 2 is equal to 10 times 2 times x minus 6 over x minus 6. I'm going to simplify each fraction individually. So x minus 6 and x minus 6 can cancel. Take 2 times x, which is 2x. 2 times 4, which is 8. And the second fraction, I can get rid of the 2's. So I have x times x, which would be x squared. X times negative 6, which is negative 6x, is equal to. In my final fraction, the x minus 6's can cancel. So I have 20. Now again, I need to rearrange my left side of my equation to get the x squared first. So I have x squared. Now I want to check 2x and negative 6x, which would get me negative 4x, plus 8 equals 20. If I subtract 20 from both sides, because I have to have it equal to 0, I have x squared minus 4x, it'd be minus 12 is equal to 0. Now that I have three terms, I have it set equal to 0, I can go ahead and factor. So two sets of parentheses. I'm going to use generic factoring. X at the beginning. I need what multiplies to 12 that can add to 4. That would be 6 and 2. I need it to be negative 4, so it would be negative 6, positive 2. Now that I'm fully factored, x minus 6 equals 0. Add 6 to both sides. So x equals 6. X plus 2 equals 0. Subtract 2 from both sides. X would equal negative 2. Before I can box my answers, I need to check for my restrictions. My restriction is going to come from x minus 6. So we know that x cannot equal positive 6, which means that this answer is no good, but my x equaling negative 2 is good. Okay? On to our final example here before our story problem. I have x plus 2, x plus 5. Neither one of those are good right now. I need to go ahead and break up my middle denominator. Well, this can factor using generic factoring. X and x. What multiplies to 10 that can add to 7? Well, it's 2 and 5. They're both positive. Okay? So my LCD is actually going to be x plus 2 is shared, x plus 5 is shared, so it would be x plus 2 times x plus 5. Okay? Since that is my LCD, I need to multiply that by every numerator I have, so to be 5 times x plus 2, x plus 5, over x plus 2 is equal to negative 1 times x plus 2, x plus 5, over x plus 2, x plus 5. I want to keep that second denominator in its factored form. I don't want to rewrite it as x squared plus 7x plus 10. I'm going to go ahead and move some of these over. Give me 1 second. Okay. Now I've taken care of my first fraction and my second fraction. So minus 3 times x plus 2, x plus 5 over x plus 5. I want to simplify each fraction individually. So the x plus 2's in the first fraction will go away. So I have 5 times x, which is 5x. I have 5 times 5, which is 25. Is equal to, both the x plus 2 and the x plus 5 will go away here, leave me with negative 1. Now before I continue, let's go ahead and cancel. So x plus 5. Before I can distribute that 3 in, though, I'm going to change this to positive and the 3 to negative. The negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Now I want to rearrange this so I have everything on the same side of the equal sign, and so it's in standard form. So I'm going to add my 3x to my 5x. Gives me 8x plus 25 equals. On this side I have negative 1 minus 6. Well, negative 1 minus 6 would be negative 7. If I add 7 to both sides, I have 8x plus 32 is equal to 0. Well, 8 and 32 are both divisible by 8, so I have 8 times x plus 4 would equal 0. Now that I'm fully factored, I'm going to go ahead and go up here. 8 equals 0, not true. X plus 4 equals 0. Subtract 4 from both sides, so x is equal to negative 4. I need to double check my answer based off of my restrictions. Well, my one restriction comes from x plus 2, which means that x cannot equal negative 2. My other restriction comes from x plus 5, which means that x cannot equal negative 5, which tells me that my x equaling negative 4 is good. Okay? On to our story problem. What I want you to know about story problems is they're all going to be set up the exact same way. You have to understand the setup. Once you understand the setup, these problems are not overly difficult. But if you do not understand the setup, they can be extremely tough. So Jason can clean a large tank in an aquarium in about 6 hours. Lacey can clean a tank in about 4 hours. About how long would it take Jason and Lacey to clean the tank together? So what we're going to do is we're going to take the amount of time. We do not know how long it is. We're going to take the amount of time, though, to set up Jason's portion of our problem. So the amount of time, we don't know what it is, so we're going to use X. We're going to divide that by the 6 hours that it takes him to clean a large tank. Then we're going to add that to Lacey's portion of the equation, which is we don't know how much time. We're going to divide it by her 4 hours it takes her. Between the two of them, they're going to get one job done, so we set that completely up to 1. All right? Now I have a problem just like I've done the rest of the time, which means I have to figure out what these break up into. 2 times 3, 2 times 2. So my LCD would be, it would be 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. So I'm going to multiply 12 by all of my numerators. So I have 12x over 6 plus 12x over 4 is equal to 12. I can simplify each fraction individually. 12 divided by 6 would get me 2, so 2x. 12 divided by 4 would get me 3, so 3x will equal 12. Now I can combine like terms, so 5x is equal to 12. If I divide by 5, I get x is equal to 2.4 hours. So it's much faster if they do it together. If you ever are working through a story problem and you get an answer that is larger than the amount of time that the individual can work through the problem, or work through the scenario, then you have done something wrong, okay? So the most important information that we learned in this lesson is that if I have more than one fraction on either side of the equal sign, I'm going to find my LCD, multiply the LCD by all of the numerators, then I'm going to simplify each fraction individually, then I can combine my pieces, factor, and solve. Once I have solved, I have to double check my answers against my restrictions. If they are not one of the restrictions, then my answer is good. If they are one of my restrictions, it'll just be canceled out and it will not exist. Well, thank you very much for watching the video. Remember, if you have any questions, bring them to me. Let's keep you guys caught up and rolling day to day. Otherwise, thank you very much. Have a great day.